Hello class! Today we're going to do lesson 6.7, which is about probability and odds. So there's a lot of new vocabulary with this topic, and the first one that I want to talk about is outcomes. Outcomes are the possible results of an experiment. So for example, flipping a coin 10 times, the possible outcomes would be you could get heads or you could get tails. So it's what could happen. Event is the next vocab I want to talk about, and that really means the outcome or a collection of outcomes. So really like what actually happened. So if I flipped it 2 times, if I flipped a coin 2 times, maybe the first time it got heads, that was one event, and the second time it got tails. Okay, what actually happened? Favorable outcomes, that means what happened, the outcome for a specified event. And then we have probability, which is really the measure of the likelihood that the event will occur. So a lot of times we talk about probability when we're talking about weather or the likelihood of a certain team winning a baseball game, for example. Theoretical probability, that is what is expected to happen based on the possible outcomes, assuming equal likely events. So for example, if I flip a coin 10 times, because there's 2 sides, I would expect that I would get a heads 5 times, and I would get tails 5 times. That's what I would expect would happen. That would be called the theoretical probability. Experimental probability is like what actually happened. So maybe I got only 2 heads and 8 tails if I flipped a coin 10 times. Okay, experimental probability, it's the result of an experiment or simulation after a large number of times. So really what actually happened. Alright, then we've got these 2, odds in favor and odds against. Odds in favor means number of favorable outcomes to the number of unfavorable outcomes. I'll get into examples in a bit. And then odds against would be the number of unfavorable outcomes to the number of favorable outcomes. So kind of the reverse. Okay, so a great way to learn this stuff is to actually get into some examples where we can use some real numbers. But I do want to talk about the probability of an event. Okay, and this is kind of like a formula, I guess, that you could think about. So the probability of an event when all outcomes are equally likely. So that is the number of favorable outcomes on top and the number of possible outcomes on the bottom. Alright, so what does this actually mean? So example 1. Suppose you roll a number cube. What is the probability that you roll the following? So we're finding probability here. So that's where we're going to be using this formula. Okay. Now, keep in mind that a number cube includes the numbers 1, 2, 3, 4, 5, and 6, just like a regular dice, okay, or die. So an odd number. So we want to find the probability of it rolling an odd number. Well, what are the possible odd numbers? I'm going to write them down here. The odd numbers in using this number cube are 1, 3, and 5. What are the possible outcomes? So the possible outcomes, well, we said that there are 6 numbers. Whoops. So there are 6 possibilities. Okay? So we've got this one right here. We've got 3 total, and the possible outcomes we've got 6. So we've got 3 over 6 would be the probability, which simplifies to 1/2, or 1/2 is the same as 50%. If I divided 1 divided by 2, that's 0.5, so is 50%. So either way that you write that, 1/2 or 50% is okay with me. Okay, now letter B, a number less than 5. So numbers less than 5 include the numbers 1, 2, 3, and 4. So we have 4 total there. Okay, and remember, possible outcomes is still our 6. Okay, so that means we have the number 4 over 6, which simplifies to 2 over 3. You could divide both those by 2. And if I did 2 divided by 3 on my calculator, that gets me 66.6 repeating percent. So either way that you write it there is okay with me. Okay, and letter C, a number that is a multiple of 3. So again, keep in mind if I have a die, so my possibilities here are 1, 2, 3, 4, 5, and 6, okay? A multiple of 3, that means like 3, 6, 9, 12. So 3 is a multiple of 3, and 6 is a multiple of 3. So there are 2 possible outcomes there, or excuse me, 2 favorable outcomes, and there are still 6 possible outcomes because there are 1, 2, 3, 4, 5, 6 numbers. So 2 over 6 simplifies to 1 over 3, and if I wrote that as a percentage, it would be 33.3 repeating percent. So again, either way that you write it, 1/3 or 33.3 repeating percent is okay. Okay, the next one that we're going to talk about is experimental probability. And the experimental probability of an event is the number of successes over the number of trials. Okay, so let's take a look at example 2. You plant 32 seeds of a certain flower and 18 of them sprout. So those 18 sprouting, that's a success. Okay, find the experimental probability that the next flower seed planted will sprout. Okay, so here's our formula, experimental probability formula. We want the number of successes, which we said was 18. So I'll write success here. And the number of trials here, which is 32. So we have 18 over 32, which if I divide both of those by 2, that would give me 9 over 16. And if I divided 9 divided by 16 on a calculator, just so that I have that, 9 divided by 16 on a calculator is 0.5625. So if I wanted to write that as a percentage, I can move that decimal point over 2 spots so that it would be 56.25%. So again, either way I'm okay with, 9 over 16 or that 56.25. Okay. Example 3. Suppose you randomly choose a number between 1 and 16. What are the odds in favor of choosing a prime number? Okay, so keep in mind here that the numbers between 1 and 16, that means that we have 16 total possibilities or total trials, and odds in favor of choosing a prime number. Okay, so here's the deal here. Prime numbers between 1 and 16, let's list them. Let's list all the prime numbers. So we've got 2, 3, 5, 7, 11, 13. And just a reminder, prime numbers are those numbers that are only divisible by 1 in itself. Okay? So how many total are those? That's 1, 2, 3, 4, 5, 6. That means there are 6 total prime numbers between 1 and 16. Okay? Now, odds in favor. So we saw this on the other side of the paper, but the odds in favor, what that really means is it said, I can go back to it. This was on the front side. Odds in favor, number of favorable outcomes to the number of unfavorable. So we have favorable on top and unfavorable on bottom. So I'm going to write that favorable on top and unfavorable on the bottom. Okay, so 6 would be our favorable. So how do you find the unfavorable? Well, those would be all the other numbers that didn't work. So like if we had our list here, 1 would be unfavorable, 2, 3 are favorable. 4 would be unfavorable, 5 is favorable. So we have 6, 8, 9, 10, 12, 14, 15, and 16, all the way up to 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them are unfavorable. Okay? Another way I could have done that is we had the total of 16, so I could have done 16 minus the favorable, which is 6, and still gotten 10. So there's 2 ways to find that number. So odds in favor, we have their 6 favorable over our 10 unfavorable, which simplifies to 3 over 5, or 60%, either is fine. Great, and then our very last one. What are the odds against choosing a prime number? So really this is the opposite, okay? The odds of, or how many prime numbers are there between 1 and 16? There are 6 prime numbers, okay, and there are 10 not prime numbers. So the odds against would be unfavorable over favorable. So we have unfavorable over favorable, which is the same thing as saying 5 over 3. All right, I hope you enjoyed this video. Please reach out if you have any questions, and as always, rewatch sections if you need to, pause the video if you need to go back and view something again.